Philip's doctor tells him he should add at least 1,000 more calories per day to his usual diet. Philip wants to buy protein bars that cost $1.50 each and have 180 calories, and juice that costs $1.20 per bottle and have 80 calories. He doesn't want to increase his daily budget by more than $12. We're asked to write a system of inequalities that models the situation, graph the system, and then answer a couple other questions. There are two unknowns in this problem, the number of protein bars and the number of bottles of juice. So I'm going to let x represent the number of protein bars, and I'm going to let y represent the number of juice bottles. So now I'm going to try to write a system of inequalities. We have two constraints on the problem, calories and budget. So let's write one constraint in terms of the calories. We want to add at least 1,000 calories, and that's made up of 180 calories for the protein bars and 80 calories for the juice bottles. There are X protein bars and Y juice bottles. So we can then say that 180 times the number of protein bars plus 80 times the number of juice bottles must be at least 1,000. So greater than or equal to 1,000. We also have a budget constraint. We need to keep the budget. We don't want to increase the budget by more than $12. Each protein bar costs $1.50. So we have $1.50 times the number of protein bars, and each juice bottle costs $1.20. So $1.20 times the number of juice bottles, and not more than 12. So that's less than or equal to 12. So there's our system. And now let's graph the system. And I'll assume a scale of 1s on each axis. So 1, 2, 3, 4. Here's 5 on the x-axis. And 1, 2, 3, 4. Here's 5 on the y-axis. And I'll work in blue for the first inequality. 180x plus 80y is greater than or equal to 1,000. I'll use the intercepts method to graph the boundary. So if I let y equal 0, then I have 180x is 1,000. And so using a calculator, 1,000 divided by 180 is about 5.56. So we have 5.56 comma 0. And letting x equal 0, we would have 80y equals 1,000. And so y, going through some division here, is 12.5. So we have the ordered pair 0, 12.5. We would use a solid line to mark the boundary. So let's see, 5.56 is about here. And 12.5, 5, 6, 7, 8, 9, here's 10, 11, 12.5 is there. And I'll draw a solid line through those points. And if we test 0, 0, and this one should be fairly obvious. 180 times 0 is 0. 80 times 0 is 0. Is that greater than 1,000? That's false. So for that blue line, for the first inequality, we would be shading above that line. Let's graph the second inequality. Using similar methods, if I let y equal 0, then I would have 1.5x equals 12, and x equals 8. And if I let x equal 0, and so that gives me the point 8, 0 on the boundary. And if I let x equal 0, then I would have 1.2y equals 12, and that would give me y equals 10. So I'd have the point 0, 10 on the boundary. So 8, 0, 5, 6, 7, here's 8, 0, and 0, 10 is here. And again, I'll draw the solid line through those points. And I'll test the point, again, I can test 0, 0. And that would give me that 0 plus 0 is less than 12, which is true. So I'd be shading below that red line. Now also, realistically, you have to have a positive or 0 number of protein bars in juice bottles. So the area, the region representing the solution that's above the blue, below the red, but where all values are 0 or positive, would be this triangular region right there. So now, let's answer part C. Can he buy 2 protein bars and 6 bottles of juice and meet both conditions? Basically, that's saying, is 2, 6 in the region? Well, 2, 6, 2, 6, here's 2, 6, there's that point 2, 6. Is that in the shaded region? No, it is not. Can he buy 6 protein bars and 2 bottles of juice and meet both conditions? Well, let's see. Let's look at the point 6, 2. 6, 2 is right here and is in the shaded region. Yes, it is.